Quadratic functions and their graphs. A quadratic function can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are constants, with a not equal to 0. Let's talk a little bit about the anatomy of the parabola. First, a parabola is going to have this cup-type shape, almost a V, but it's curved. The vertex is the lowest point of the parabola if it opens up, and it's the highest point on the parabola if we have a parabola that's opening down. We also refer to this as the minimum of the parabola or the maximum of the parabola because it would be the lowest or the highest point. The axis of symmetry is this line that we could draw down the middle of the parabola, that if we fold over the parabola, the left side lies on the right side. Its equation is x equals h, which will be the x part of our vertex. The vertex will be hk, and so the axis is that vertical line x equals a constant, and it's the x equals the x part of that vertex. In the vertex formula, the x-coordinate of the vertex of the graph of y equals ax squared plus bx plus c, with a not equal to 0, is given by x equals negative b over 2a. To find the y-coordinate of the vertex, we'll substitute this value into the original equation of the graph. So really, a lot of people will write the vertex formula like this, that the x part is negative b over 2a, and the y part is f of negative b over 2a. Simply placing the x value that we found here into the f function to get the y part. Let's find the vertex of the parabola using the vertex formula. First, let's find the x. Remember that x is negative b over 2a. So our a is 1, b is negative 4, and c is negative 2. A, b, and c are the coefficients of that equation when the equation is in descending order. So we'll have a positive 4 over 2 times a, which is 2, and that gives us 2. So we have the x part of the vertex. Now to find the y part, we'll simply take the x that we got, put it into the function, and then we'll simplify, and that will be our y part of the parabola. So we get a 2 squared is 4, minus 4 times 2, which is 8, minus 2. 4 minus 8 is negative 4, minus 2 is negative 6. So here we have the vertex of that parabola. Use the given graph of f to evaluate the expressions. Again, f of negative 3, we've put negative 3 in place of where the x usually is in function notation. So they're telling us that the x is negative 3. So let's find the place on the graph where x is negative 3. We find it there, we go down, we have this point, negative 3, negative 2. So f of negative 3 is negative 2. F of 1. So we're finding the value of the function when x is 1. So x is 1 here. And we have the point 1, negative 2. So f of 1 is negative 2. Let's identify the following from the graph that's given. First, the vertex. Remember that the vertex is the lowest or the highest point on the parabola. It's the lowest point on the parabola if it's opening up. So that would be this point here. So we have the point 1, -2. The axis of symmetry is that vertical line that we could draw through the middle of that parabola, and its equation is x equals the x part of the vertex. Does the parabola open upward or downward? This one opens upward. Remember, if it opens up, it's like a cup. If it opens down, then it's like a frown. The graph of y equals ax squared. The graph of y equals ax squared is a parabola with the following characteristics. Our vertex is going to be 0, 0, and the axis of symmetry is given by x equals 0. Remember, the x equals the x part of the vertex, so here it's just x equals 0. It opens upward if a is greater than 0, if a is positive, and it opens downward if a is less than 0, if a is negative. It will be wider than the graph of y equals x squared if the absolute value of a is between 0 and 1, and it will be narrower than the graph of y equals x squared if the absolute value of a is greater than 1. Let's look at the graph of f of x equals ax squared. Here we have our basic parabola, y equals ax squared. Here a is 1. So this is what a usual parabola is going to look like for us. Now what happens is if we move this slider, let's say we make the a our coefficient right here, let's make it instead maybe a 2. We can slide it over to 2. So now the equation is g of x equals 2x squared, and you can see that's the blue equation. Okay, and the gray equation you can see is the standard parabola f of x equals x squared. So when we made the coefficient, the a, 2, then it made the parabola look narrower. If we move it to a negative number, let's say we move it to a -1, then it's the same width and shape as the original gray parabola, but it's upside down. So when we have a negative value for a, -x squared, then it's going to be opening down. And let's go ahead and make this a, maybe make it a -3. So when we make it a -3, it's even more narrow than the g of x equals 2x squared was. Now let's go back, look at the positives on this. Let's say that we make our parabola have a coefficient that is between 0 and 1, where the absolute value of that is between 0 and 1. Then it's making the parabola look wider than that gray parabola. And over here, go here, let's make it a -0.4. So here's our new equation. Of course, the negative means it's opening down, but the coefficient being between 0 and 1, the absolute value of it being between 0 and 1, causes that parabola to be wider than our standard f of x equals x squared parabola. So let's do the following for the given f of x. Identify the vertex and axis of symmetry of y equals f of x, and then we'll graph y equals f of x and evaluate f of -2 and f of 3. So first, identifying the vertex. Remember, the vertex we find by x first is -b over 2a. -b is going to be 0 because I don't have a plain x term, so it must mean that this equation is actually x squared plus 0x minus 2. So the b is 0, and negative of b is still 0. 2 times a is 2 times 1. So we're going to get a 0 out of that for our x. So I know my vertex is 0 for the x. Let's find the y. Remember, we put the x part that we found back into the equation. So 0 squared minus 2. 0 squared is 0 minus 2 is negative 2. So our vertex is 0, negative 2. There we are. And our a here, just to observe this, we have a 1, so it's going to be the same width as our standard parabola that doesn't have another coefficient in front. Let's look at finding the axis of symmetry. Remember, the axis of symmetry is x equals the x part of the vertex, so x equals 0. And then we'll graph this. When we are making our parabola, then we want to make the vertex be the center point in our t-table. And we'll pick points, a couple of points away either side of that vertex. So let's go negative 1, negative 2 on this side, and a 1 and 2 on that side. If we put in a 1, 1 squared is 1, minus 2 is negative 1. Put in a 2 squared is 4, minus 2 is 2. Put in a negative 1 squared is 1, minus 2 is negative 1. And put in a negative 2 squared is 4, minus 2 is 2. And like we said, the axis is the symmetry line. So you can see here we've put the x part of that axis here, and you can even see symmetry in the table when we do that. Let's go ahead and put our points down. Negative 2, 2, negative 1, negative 1, 1, negative 1, 2, 2. So here we have our nice graph. Just make it as smooth as you can. Make sure that you're not making it flat edged, that it actually has a little curve to that. And now we'll find f of negative 2 and f of 3 as asked in part C. So f of negative 2 we already have here is 2. What is f of 3? If we put 3 in, we'd have 3 squared is 9, minus 2 is 7. So f of 3 is 7. For this quadratic function, let's go ahead and find the vertex. So the vertex is x equals negative b over 2a for the x part. So negative b is going to be negative 1. 2 times a is going to be 2 times 1. So I get a negative 1/2 for the x part of the vertex. And now to find the y part, we're going to plug that negative half back in. So f of negative 1/2 is negative 1/2 squared plus negative 1/2 minus 2. So that's a 1/4 minus 1/2 minus 2. And if you like, you can grab your calculator and let your calculator do this. So 1/4 minus 1/2 minus 2, and that's going to get me as a fraction a negative 9/4. So my vertex is negative 1/2, negative 9/4. Let's go ahead and make a t-table, and we'll put our vertex here in the middle. And let's go on either side. Let's say we go this way to a negative 1 and a negative 2, and this way to a 0 and a 1. If I put a negative 2 in here, that's going to be a positive 4. Minus 2 is 2. Minus 2 is 0. If I put in a negative 1, it'll be 1. Minus 1 is 0. minus 2 is negative 2. Putting in a 0, I get 0 plus 0 is 0, minus 2 is negative 2. See the symmetry there. Let's get a 1. 1 squared is 1 plus 1 is 2, minus 2 is 0. So again, we have symmetry there. So let's go ahead and graph the points. I've got negative 2, 0, negative 1, negative 2, negative half, negative 2 and a fourth, 0, negative 2, and 1, 0. So go ahead and draw the graph nice and smooth. Make sure that you show the curve in it, that it's not just a straight edged V. And then we'll go ahead and find f of negative 2 and f of 3. F of negative 2, of course, was 0. That was in the table. F of 3 we didn't have in the table. We can do that quickly here. 3 squared is 9, plus 3 is 12, minus 2 is 10. Here we'll have a parabola that's going to open down because my A is negative. So let's go ahead and find the vertex of this. The x part is negative b over 2a. So we have a negative 4 over 2 times negative 2. So negative 4 over negative 4, which is a positive 1. So I have a vertex with an x of 1. I'm going to plug that back in to find the y part. So negative 2 times 1 squared plus 4 times 1 minus 1 is 1 squared is 1 times negative 2 is negative 2 plus 4 minus 1. So I've got a 2 minus 1 is 1. My vertex is that 1, 1. And of course the axis of symmetry is going to be x equals the x part of the vertex. And let's make a t-table so we can graph. We'll put the vertex here in the middle of the table, and we'll go a couple of points on either side of that vertex. Let's go with a negative 1. If a negative 1 squared is a positive 1 times negative 2 is negative 2. That'll be a minus 4, so negative 6 minus 1 is negative 7. Put in a 0. 0 squared is 0, so that goes away. This times 0 is 0, so that goes away. So we just have a negative 1 left there. On 2, 2 squared is 4 times negative 2 is negative 8 plus 8 is 0 minus 1 is negative 1, as we kind of expect because of the symmetry here. And 3 squared is 9 times negative 2 is negative 18 plus 12 is negative 6 minus 1 is negative 7. Again, following through the symmetry. So I have a negative 1, negative 7, and I have a 0, negative 1. I have a 1, 1. I have a 2, negative 1, and a 3, negative 7. So you can see our parabola is opening down, and it's also narrower than our standard y equals 1x squared type of parabola. Let's find our f of negative 2 and f of 3. So of course f of negative 2 we didn't put on our table, but we can go ahead and put it up in here. So a negative 2 squared is positive 4 times negative 2 is negative 8 plus a negative 8 is negative 16 then, minus 1 is negative 17. And f of 3 was in our table, so we can just copy that down. Let's find the minimum or maximum y value on the graph of y equals f of x, and we'll be sure to state whether it is a minimum or a maximum. So first, when we are asked about a minimum or maximum y value, they're really asking us for the y part of the vertex. So we need to find the vertex. We just need the y part, but in order to get the y part, we have to get the x part. So let's start there. X is negative b over 2a, our vertex formula. So negative of b is negative 2 over 2 times a, which is 2 times 1, is negative 2 over 2, which is negative 1. So if we are finding the vertex there, the x part is negative 1. Let's find the y part. So we put in our negative 1 for x in the function. And I get a 1 minus 2 minus 1. So that is a negative 2. So we know that the minimum or maximum y value on the graph is that y part, the negative 2. Now we need to state whether it is a minimum or a maximum. So the way you would know if it's a minimum or a maximum is if this thing is opening up or down. So let's see, we have a positive coefficient of x squared. So that means that we're going to be opening up. If this is a positive number, then our parabola will be happy. Okay, so if a is positive, then we have a happy. And if this is a negative number, if a is negative, then we're going to have a sad parabola. So this is a parabola that's opening up. So the vertex is going to be the lowest point on the graph, or in other words, the minimum. So we have a minimum of negative 2. Let's find the maximum or minimum of this one. We can actually tell right now whether it's going to be a maximum or a minimum. We have an a value that's negative, so a is negative. It makes our parabola sad. So the vertex is going to be the highest point on the parabola. So we know that we're going to have a max. And now we just need to find the vertex so that we can take the y part out of it, and that would be our maximum. So let's go x equals negative b over 2a. So that's negative 2 over 2 times negative 1. So negative 2 over negative 2 is positive 1. Let's do f of 1. So negative 1 squared plus 2 times 1 plus 5 equals, this will be a 1 squared is 1 times negative is negative 1 plus 2 plus 5. That gives me a 6. So the maximum value of y is 6. Let's complete the following table. For each of these parabola functions, we're going to decide whether it opens up or down, whether it's the same, wider, or narrower than our standard y equals x squared parabola. We'll identify the axis of symmetry in the vertex and find the x-intercepts and y-intercept. So let's find out whether this one opens up or down. First, please notice that the parabola equation is not in standard form. This is actually our A and this is our B. So we have the A here as a negative, which means our parabola will be opening down. Is it the same, wider, or narrower? Well, the absolute value of negative 1 is positive 1, so it's the same as our y equals 1x squared parabola. The axis of symmetry, we're going to use our formula x equals negative b over 2a. So the negative of b is negative 2, and 2a is 2 times negative 1. So I have negative 2 over negative 2, which is positive 1. So we'll write the axis of symmetry as that equation of a vertical line, x equals 1. And to find the vertex, well, we know that the x part of the vertex is 1. And we'll find the rest of it by putting in 1 for x. And that gives me a 2 times 1 is 2, minus 1 squared is 1, 2 minus 1 is 1. So I have the vertex 1, 1. Let's find the x-intercepts. Now the way we find the x-intercept for a parabola is the same as we have found the x-intercept for any other type of function. So to find an x-intercept, we make y 0. So we're going to take the entire f of x, which is the same as y, and make it a 0, equals 2x minus x squared, and then we solve that. So 0 equals, I'm going to factor out an x, and that gives me a 2 minus x. So x equals 0 here, and x equals positive 2 here. So I have two x-intercepts of 0, 0, and 2, 0. And to find the y-intercept, I make the x0, which is quite easy. We just put 0 in here, and here, all of that goes away, so we have the y-intercept 0, 0. For this equation, it's going to be opening, of course, up, because a is a positive number. And is it the same, wider, or narrower? Well, this is a 2, and the absolute value of 2 is 2, which is bigger than 1. So it's going to be a little narrower than our standard y equals x squared parabola. The axis of symmetry is going to be x equals negative b over 2 times a, so that's a x equals negative 2 over 2 times 1, which is 2, so we get a negative 1. And the vertex will be negative 1 for the x, and we'll find the y by putting negative 1 in. So I have f of negative 1 is 2 times negative 1 squared plus 2 times negative 1 minus 4. That gives me a negative 1 squared is 1 times 2 is 2, minus 2, minus 4. So I have a negative 4. So negative 1, negative 4 is the vertex. X-intercepts, again, I would make y 0. So I have 0 equals 2x squared plus 2x minus 4. So let's factor out a 2. That gives me an x squared plus x minus 2. And that trinomial factors as x plus 2, x minus 1. So I have an x equals negative 2 and an x equals 1, which means I have two x-intercepts of negative 2, 0, and positive 1, 0. And the y-intercept, again, we're making x's 0, so those two terms go away, and I have just the negative 4 left. So I have the y-intercept 0, negative 4. And let's look at this equation. Does it open up or down? Well, this is a negative there, so we're going to say this one opens down. And is it the same, wider, or narrower? Again, the absolute value of negative 3 is positive 3, which is bigger than 1. So this is going to be a narrower parabola than the standard y equals x squared parabola. The axis of symmetry, let's go ahead and start with that. That's x is negative b over 2a. So we have negative b is going to be negative 6 over 2 times a, which is negative 3. So I have negative 6 divided by negative 6 is positive 1. So x equals 1 is our axis of symmetry for this. And the vertex, I'm going to put the 1 back in, so f of 1 is negative 3 times 1 squared plus 6 times 1. So that's a negative 3 plus 6, which is 3. Gives me the vertex 1, 3. And to find the x-intercepts, we make y 0. So 0 equals negative 3x squared plus 6x. So let's factor out a negative 3x. That gives me an x minus 2. So from this I get an x equals 0, and from this I get an x equals 2. So I have two x-intercepts, 0, 0, and 2, 0. And for the y-intercept I make x 0, so both of those terms go away, and I have a 0, so I have the y-intercept 0, 0. The height reached by a baseball. Quadratic functions model our parabolic flight of a ball, or any kind of projectile will have the parabolic type of motion. So you'll see this a lot when we're talking about objects that are falling or being thrown into the sky and coming back down. Here a baseball is hit into the air, and its height h in feet after t seconds is given by h of t equals negative 16t squared plus 64t plus 2. What is the height of the baseball when it is hit? So when we're asked a question, they have to give us some part of that problem. They can't just ask us the question without any type of hint of where we're coming from. Here they have given us the hint, you just have to really look for it. The question says that it's hit into the air, the height h in feet, and t seconds. So we have the height of the baseball when it is hit. We're finding the height when it is hit. So if we're asked to find the height, we need to know what the when is. And the moment that that ball is hit is t equals 0, because t is the seconds after it was hit. So we know here that t equals 0, and that will help us to find the height of that baseball. So let's come down here. We go h of 0. In other words, the height of the ball at time 0, at the very moment it was hit, is negative 16 times 0 squared plus 64 times 0 plus 2, which is just 2. So the height of the baseball when it was hit is 2 feet, because our h, our height, is measured in feet. After how many seconds does the baseball reach its maximum height? So whenever we're asked for something that says maximum or minimum, it's asking about something from the vertex. So what we need to do here is identify the vertex. Now the vertex is going to be not an x, y type of thing here, or hk. It's going to be here, my x is the t, and then the y is going to be the h. So what part of the vertex are they asking for here? After how many seconds? So they're asking for the x part of the vertex here. And we know to find the x part of the vertex, we use x equals negative b over 2a. That gives me a negative 64 over 2 times a, which is negative 32. So that's a 2. So after how many seconds does the baseball reach its maximum height? 2 seconds. And part C, determine the maximum height of the ball. So the maximum, again, it's asking for something about the vertex, and it's asking for the height, and we've identified that the height is the y part of the vertex. So we'll put in the x part of the vertex back into the function and find the y part. So h of 2, or in other words the height of the ball at 2 seconds, is negative 16 times 2 squared plus 64 times 2 plus 2. So 2 squared is 4 times negative 16 is negative 64 plus 64 times 2 is 128 plus 2 is going to be 66. So the maximum height of the ball is 66 and our unit feet. That covers this lesson. Go ahead and try your homework. Be sure to let me know if you have questions.